Today we're going to be calculating trigonometric ratios given one ratio. So everything we've seen so far have been on the unit circle. What happens if they're not? So we're going to be given one of them, and then we're going to have to use that information and only that information to find the remaining 5 trig ratios. So in this case, we're given the sine of theta equals 5/13, and we're in the first quadrant, and we're going to find all 6 of them. So I'm going to set everything up here. We know that we need to find all 6 of these. So sine, cosine, tangent. Sine doesn't start with c, so I need cosecant to go with that. Cosine starts with c, so I need secant to go with that. And then we know that cotangent goes with tangent. Sine is 5/13. They told us that. Okay, so now that we know that information, we can figure out the cosecant is just the reciprocal. So that should be pretty easy for you to figure out and get 13/5 for the cosecant. Now, for the rest of this, we got to look at our triangle. So we're in the first quadrant, and no matter where we are, we know that our angle needs to be coming from here. Remember, it's still like we have that XY coordinate plane, and so we need our triangle to look like it's part of a bow tie, whatever quadrant you're in. It's coming from the center here and then out. All right, so sine is opposite over hypotenuse. So we know that the opposite side here is 5 and the hypotenuse is 13. And then now we got to figure out what we're going to do to figure out the rest of this. That means that we do have a right triangle here, and we have to figure out what the third side of the right triangle is by using Pythagorean theorem. So this is the x. So we would have x squared plus 5 squared equals 13 squared. So that would give us x squared, plus 25 equals 169. This is where your perfect squares come into play. That would give us, if we subtract 25, x squared equals 144. So x is going to equal 12. Okay, so that side right there is 12, and we are in the first quadrant, so that x would be positive. There are the Pythagorean triples that you learned in geometry as well. So 5, 12, 13. If 5 is a leg and 13 is the hypotenuse, then 12 has to be the other leg automatically. If the 13 was here, then that does not mean that this side is 12. Remember, the hypotenuse needs to be the longest side of your triangle. So if you remember your Pythagorean triples, you don't need to do this math here to figure out what the third side is. You could just automatically know. Okay, but if you don't, you can do this math. All right, so now the cosine, we're coming from this angle here. The cosine is 12 over 13 because it's adjacent over hypotenuse, which means that secant, we're going to flip that to be 13 over 12. And then tangent is opposite over adjacent. So this is going back and using your SOHCAHTOA stuff. All right, so I'm going to write that up here at the top. Okay, when you are not on the unit circle, it's best to use SOHCAHTOA. So tangent is opposite over opposite over adjacent. So that would be 5/12. And cotangent then is just the reciprocal of that 12/5. Now you could still use the fact that tangent is sine over cosine. If you take 5/13 and divide it by 12/13, you're going to get 5/12. So it's up to you. I think it's just easier to use SOHCAHTOA though. All right. So given just one of them, we're going to be able to use that information to figure out the rest of the triangle pieces. All right, so let's take a look at another one. Here we are given that the cotangent of theta is -5/4 in the second quadrant, and we're going to find the remaining 5. So technically you don't need to write all 6 of them out. I just find it easier to use what I've already been given to build the rest of my stuff. Okay, so we know that this is -5/4. All right, let's build our triangle. We're in the second quadrant, so that means that our angle would come like this, like it's part of a bow tie in the second quadrant. Now, cotangent is -5/4. That's not so easy to look at. I always like to try and get them back to sine, cosine, and tangent. So here we know that the cotangent is negative 5/4. To go back to the tangent, we're going to flip that, and we're going to leave the negative in the numerator, okay? So we know that tangent is opposite over adjacent. So I'm going to take this, the opposite would be 4 and the adjacent would be 5. Now you notice I didn't put the negative down anywhere yet. Just because the negative is attached to the 4 there doesn't mean that it's supposed to be, because over here it was attached to the 5. So if we're in the second quadrant, which of these would be negative? If we go left or if we go up? So if we go left, that's going to be negative. That means that we are going to make the 5 be negative. All right, so now we are going to find the third side of this triangle before we go any further. So here, this is our hypotenuse, so I'm just going to call it that. We'll call it H, sure. You can use whatever letter you want. So we know that 4 squared plus negative 5 squared equals H squared. So 16 plus 25 equals H squared. 16 and 25 makes 41. So that means that H would equal the square root of 41. So it's okay if it's not a nice easy number. The square root of 41, we can't simplify it all, but if that was something that you could simplify more, then you're going to actually simplify it, okay? So if it was the square root of 12, let's just say, then you would simplify it to be 2 radical 3. All right, so we have radical 41 as our hypotenuse there. All right, so now we're ready to find everything else that we need. Okay, sine is opposite over hypotenuse, so we would have 4 over radical 41. But remember, we can't keep it like that. We have to rationalize. So we get 4 radical 41 over 41. And that doesn't simplify there. That 4 and that 41 don't simplify. Cosine, we would get adjacent over our hypotenuse, but we have to rationalize that as well. So we get negative 5 radical 41 over 41. And then for cosecant, we're going to flip the sign. Instead of flipping this, that we would have to rationalize again, I'm actually going to go back to this, this part here. And that's why I'm going to strongly suggest that you're writing out all of your steps for things so you can go back and see this, that if we have 4 over square root of 41, when we flip it, it's just going to be radical 41 over 4. And here, if we flip the negative 5 over radical 41, instead of flipping this, it's going to be a lot easier. So we would get radical 41 over 5, and then we're going to keep the negative in the numerator. Okay? So there we have taken all of that information and put it together to find all 6 trig ratios. So let's look at one more. Here we are given that the cosecant of theta is equal to negative 21/12, and we're in the third quadrant. So one thing that I noticed right away with this one is that 21/12 can be simplified. So I'm going to simplify that. They are both divisible by 3, so I'm going to make that be negative 7/4. You don't have to do that, but this is going to make our numbers be a lot smaller and easier to deal with. So I'm going to highly suggest that if you can simplify your fractions, you are simplifying them. All right, so we have to find sine, cosine, and tangent. And then cosecant, which they told us is negative 21/12, but I'm going to simplify that, like I said, to negative 7/4. So here we've got all 6 of them that we need to find. And before we draw our triangle, we know that cosecant and sine are reciprocals of each other, so that means that we're going to have 4/7, and the negative is going to stay in the numerator. All right, so now let's use that information. We're in the third quadrant, so the part of our bow tie is going to be down here. And it doesn't matter what your triangle looks like, as long as it's in the correct quadrant, and it should be a right triangle. I didn't do a very great job here, but that's okay. All right, so sine is opposite over hypotenuse. And again, I didn't put the negative there yet, but only one of them can be negative. So in this case, or in any case, when you're dealing with these types of triangles, for anything, your radius is always positive, okay? Even though it's going in the downward direction, your radius is always positive. So that means that we would go down 4, which means that 4 is negative, okay? So now we're going to use this information to find the third side of our triangle. So this is the x coordinate. So we're going to say x squared plus negative 4 squared equals 7 squared. And you shouldn't need a calculator for any of this information. Should all be pretty basic math for you to be doing. If we subtract 16 from both sides, we get x squared equals 33. So that means that x is going to equal the square root of 33. And that doesn't simplify at all either. Now, be careful because this is going left, so that radical 33 does need to be negative. Okay, remember what quadrant you're in. All right, so to finish this off, cosine then would be, we're focused at this angle there. The cosine would be the adjacent over the hypotenuse. Secant, we're going to flip that. So we would have negative 7 over radical 33, but we know we're going to have to rationalize. So I'm going to go ahead and do the rationalization without writing it down. If that confuses you, then write it down. If you got that, then you got it. It's good. Okay. Tangent, you could do sine over cosine if you want, but I'm going to just suggest that we're going back here. So we have opposite over adjacent. And I wrote this down here because I knew I was going to have to do some simplification. Tangent is going to be the one that I'm going to highly, highly suggest that you're writing work out for. Okay, so we know that a negative divided by negative is a positive, and we would need to rationalize here. So we would get 4 radical 33 over 33. For cotangent, you can flip this. It's going to get a little ugly. Not undoable, just a little ugly. So let's just flip this here. What we got before we rationalized for the tangent, which means we would have radical 33 over 4 for our cotangent. Okay, so it is going to give you one trig ratio. It's going to tell you what quadrant it's in, and you're finding the other 5. So you're going to draw the picture, you're going to find the third side, and then work on finding those trig ratios using SOHCAHTOA. And that's it.